a success story at Barrick Cortez for real-time geotechnical and hydrology monitoring. Barrick's challenge was to monitor in real time more than 280 piezometer wells on surface and more than 100 hydrology and geotechnical instruments underground to ensure the mine is safe and can be mined as planned in the proper sequence without interruptions from fall of ground. These are the actual locations of the instruments at the mine site. Newtrax Technologies, a firm specialized in wireless telemetry, and Mine Design Technologies, a firm specialized in geotechnical instrumentation, accepted the challenge and designed a world-class multi-hop wireless telemetry system to continuously monitor the sensors and relay the information back to a web interface. The solution contains 3 system components: Ethernet gateways, MineHop wireless nodes, and geotechnical and hydrology instruments. The combined system is plug-and-play, truly wireless, and the batteries last for years, so it's very simple and does not interrupt production. Now let's see how it works underground. First, the central server is installed in the server room on the surface and connected to the mine's Ethernet network. The Ethernet gateway is connected to the network with power over Ethernet, so both power and communication are supplied directly by one cable. The first wireless node is then connected directly to the gateway with a rugged 20-foot cable. Finally, the wireless nodes are positioned as repeaters to enable the signals from the MDT smart instruments to hop back to the gateway. Installing MineHop nodes is very simple. When the node is turned on, it will automatically connect to the network. As the user walks away, the status LEDs will change from solid green to blinking green, then blinking red to solid red as the received signal strength drops from good to bad. The user picks a location where the signal strength is good and mounts the node in place using tie wraps. This process is repeated until network connectivity is extended to the target location for instrumentation. Now let's see how the installation goes at Barrick Cortez. Here we are getting ready to install the Smart MPBX instrument. Drill a hole, uncoil the instrument and tape it to a grout tube. Insert it into the hole and grout to the collar. Then connect the wireless RTU node to the sensor's lead wire connector. Up to 3 MDT smart instruments can be connected to each MineHop wireless RTU node. The final step is to configure the sampling rate, sensor thresholds, and email alarms from the web interface, so you can be informed anytime, anywhere. On surface, it's just as simple. The Ethernet gateway is connected to the network inside a surface building. The first network node is installed with a 20-foot cable and mounted on the outside of the building. All other nodes are installed at each piezometer location for simple data collection, especially where locations are hard to access by ground. The wireless RTU is typically mounted on top of a pole and connected to a 12-foot cable that links it to the piezometer in the well. Up to 4 vibrating wire piezometers can be monitored with one wireless RTU. Install all of your nodes and be ready to collect data at your desk in the simplest way. The wireless sensor network deployed both underground and on surface at Cortez has several hundred nodes. Now let's see what the engineers here at Cortez think of the whole solution.
So Cortez is kind of a unique mine because we have actually 2 open pits. We've got the Cortez pit and Pediment pit. And we are mining underground at the same time, so we're mining directly underneath the pit. So this forces us to plan ahead several years, and that's why we have to make sure we monitor our groundwater levels so well so that we can make sure that we mine efficiently and cost effectively. Some of our piezometers can be in some pretty remote locations here. So having a wireless network allows us to download the data remotely so that way we don't have to travel to every piezometer and download that data. This allows us to save time, and in the end, that's leads to cost savings. At Barrick Cortez, we have over 200 wells and piezometers that need monitoring.
Right now, we have a pretty large pit mining up above us. Our uppermost level is at 4805, above from sea level. So we have our smart MPBXs installed throughout several muck bays in that drift, all already wired up and collecting data. It turns a 15-minute commute into a 2-minute commute. So we need to make sure that as the pit bottom gets closer to us, this drift stays open, not only for safety, but for production as well. People who benefit the most from this information that's collected by the Newtrax system, I'd say, is everybody at the mine. Just because we're keeping our excavations open, we're able to monitor any sort of ground movement that we can see. So I feel that since we can see that, everybody, you know, from typical day visitor to a seasoned miner underground, or me, or the rest of my department, engineering, geology, whoever. So having the sort of connectivity that's as easy as hanging up a box is pretty good, in my opinion. Saves us time, allows us to monitor everything constantly, and it's just a plus across the board.
For more details about this simple wireless sensor network solution, please visit the following websites.